Welcome folks, welcome to this next video. This is average and I have promised I'll come with average, and yes, still if you don't understand like a lot of things about like how average works, this is the right place you are, and we will discuss questions based on like the previous year questions. Also we will discuss some very interesting topic as well. But first you need to understand like why this average is important and what exactly we are going to learn in average first. So in average we learn average and weighted average, and as I have promised, like we are going with the arithmetic playlist. So we have already finished the 4 sections, now like 4 chapters mainly. Now it's our 5th chapter, which is average and weighted average. So in case of average, like we start with first average, then we'll finish something, then we'll do more questions, then we'll go for weighted average, and we will finish it aramse. And remember one thing, average is something which you should understand because the concept of average is very vast. And average is basically a very basic statistical measure. Average is a very basic statistical measure. Think about a population of country. I cannot have the data, I cannot use the data of like the per person's income, let's say. But I can find the average of the per person's income. So that's basically a representation of data. So let's say we have a data of 140 CR people, right? We have data of 140 CR people, or like let's say 1.4 billion people. But I cannot have access to like individual data. Even if I cannot use it. So I need to have something which can represent the entire data. So the representation of data is basically where we chip into statistics. And when we chip into statistics, an average is the basic measure of like the data, basic measure of data. Like what average data shows, it shows the center of the data generally. So this average, median, mode, they are central tendency of a data. How the center of the data behaves. Generally, if the center behaves in such a way, the entire data behaves in such a way, but it's a very naive belief. It's a very premature belief. But still we have this thing in our syllabus, so we need to learn how average works and what is exactly average. And think about something like we need to find average of what? Like whenever you are going for a B school, especially in the case of India, we always go for one thing mostly, mean CTC of that B school, right? Mean CTC or like median CTC. Sometimes we see of the median also, because median sometimes is much more reliable, because median is something which gives you the middle value. Let's say 1, 2, 3, 4, 5, 6, 7. So what is the middle value? The middle value is 4, and you can see that in screen, like 4 is the middle value, right? So 4 is the median, and in this case the mean is also 4. You understand, right? So in this case mean, median is same, but median has something very important feature, because if I say 4 is the median, I am sure at least half of the data is more than 4. And this kind of informations are very important when we are basically categorizing a data, right? So that's why average, these things are very, very crucial. And all these things, like after average we also have like measure of dispersion. Dispersion is how much scattered the data is, because if the data is much more scattered, the data is that bad. Right? So think about like in a cricket match, right? In a cricket match, what happens? Like whom you choose, a consistent player or an inconsistent player. Let's say a player who scores 50 in 4 consecutive matches, and a player who scored 0, 100, 10 and 90. Whom will you choose? Though their total score might be the same, their average might be the same, their median might be the same, even their mode might be the same, but still you choose the person who is more consistent. Because if you choose the person who scored in 4 matches 50, you can say if I send him to the court or if I send him to the pitch, he at least score a decent amount of run. But in case of 0, 100, 10, 90, it is always dubious whether he will score or not. It is good for 1 match, but we cannot make any kind of deal about it, because if he goes, it goes. If he doesn't go, he doesn't go. So in that case we have a lot of other factors, but if it is consistent, we can make a plan on it, right? We can have a particular plan on it, like how we can use that person, and we can be very sure like we have at least 50-40 runs in our board if she is there or he is there. That's why we need this kind of statistical measures, right? So this is the introduction of statistics, right? So let me show you some interesting thing in statistics as well, or especially in average. So think about it in this way, like this is the intro to average, right? Think about a case study. So think about this case. Let's say there are 2 players like Virat Kohli and Rohit Sharma. And Virat scored 47, 49, 50, 52, 52. Rohit scored 48, 49, 50, 50 and 53. And let's say these are a test match, because you can see both are wearing white. But they are wearing from different time frame, because one is wearing the Byju's t-shirt and one is Dream 11. This is much more like, this is like the newer one. But my question is not that. My question is that, let's say you have only one place, you need to choose one batter out of these two, famous batter. And this 5 data is only there. There is no other external data and other external factors are there. Based on this 5 data only, how can you choose one player out of Virat and Rohit? You might love Virat Kohli, you might love Rohit Sharma. That is not the case here. The case is, based on this data, how you can select one player out of these 2 players. Because this kind of decision making you have to do in your MBA. This kind of decision making you have to do in your life. This kind of decision making you need to have a very statistical, statistical and especially like a logical decision making. So statistics will help you to get a logical decision making, not by impulsion, just by using logic and analytics. So this is the question. How and who will you choose out of Virat Kohli and Rohit Sharma? Now you can give a pause here. You can check like whom you want to choose here. And after like giving your own explanation, then you can see the solution. And I am going to the solution directly. So you can take a break of like, let's say 30 seconds, 1 minute, and give a pause, think about it, then see the video again. Virat Kohli's score is 47. The score is 47, 49, 50, 52 and 52. Now if I need to do the average, if I need to do the average, one thing I can say, the first thing that comes to our mind is whose average is more. So if I do the average of Virat Kohli, that is 47, 49, 50, 52, 52 whole divided by 5. If you do the average, you will see your answer will be, average, another name is mean, arithmetic name, it is 50. Average will come 50. And if you go for Rohit Sharma as well, the average of Rohit Sharma will also come 50. If you do, like if you add all these things, if you add all and divide by 5, you'll get the average is again 50. So if the average of 2 things are equal, so then our first measure has failed. It has not given me any conclusion proof about which one I have to select. So the next thing I am going to do, I am going to find the median. So think about it, median is basically where you arrange it increasing or decreasing order. This is already being arranged, so the median is 50, the median is also 50. So your median is 50, so I cannot get any kind of result from this. Mode V is not applicable for this smaller kind of data set because mode generally not gives here. But median is also 50. So I can say half of the match he scored more than equal to 50, half of the match he scored less than equal to 50, right? So median is not also giving me any kind of conclusive decision making tool, right? So next what we will see, next we will check range. What is range? Range is maximum minus minimum. Now think about it, this is the measure of dispersion or scatteredness. If the range is small, the data is better. If the range is bigger, the data is small. Between 0 and 100, what is the range? 100, maximum minus minimum. Between 51 and 49, what is the range? 2. So which one is the better data? The range with a lesser range. So the less the data is scattered, the better the data is. Okay? So range is max minus minimum. So what is VK's range? VK's range is 52 minus 47, which is 5. What is Rohit Sharma's range? That is again 53 minus 48, that is 5. So both range is also same. So whenever we have the range also same, the next thing we slowly we're going to do, we need to find the standard deviation or the deviation. Now general deviation won't make any difference. Why? Because general deviation is almost as same as that. So what we need to do, we need to find the deviation and do the square. If we just do the deviation and add subtract it will become 0. But if we find the deviation from mean and do the square of it, then we have, this is a kind of concept of standard deviation, then we can have a better understanding. So think about it here. What is the deviation? That is 3. That is 50 minus 47. 50 minus 47, what is it? 3. So 3 square. That is minus 3, so minus 3 square. What is it? Minus plus minus 1 square. What is it? 2 plus 2 square. What is it? Again 2 plus 2 square. Okay? So what is the deviation here? The deviation here is 10 plus 4 plus 4, 8. So this deviation I can calculate. That is the square of the deviation is basically nothing but 18. Now think about in case of Rohit Sharma. In case of Rohit Sharma, that is 4850. That is minus 2 square. Yes. This is minus 1 square. Cool. This is 0 square and this is 3 square. Clear? So how much I am getting? That is 9, 10 and that is 14. So whose deviation, whose square of deviation is less? Rohit Sharma's square of deviation is less. So if Rohit Sharma's square of deviation is less, so we definitely choose Rohit Sharma over any other person. Like any other matlab Virat Kohli. Because Virat Kohli's deviation is 18 and Rohit Sharma's deviation is only 14. So the less deviation, the better the data. So whom I choose? I'll choose Rohit Sharma. So this is the application of like average, make these kind of things like this deviation, range, scatterness, central tendency in a real life. I hope you have enjoyed this, right? So now we'll go forward from here. Finding average by deviation method. So we need to find average by what? Deviation method. Now what is a deviation method? Okay? We need to learn what is exactly a deviation method and what we generally do with deviation method. So think about some numbers. Let's say think about some numbers like 47, 52, 56, 50, 45. Okay? So if these are the numbers and I need to find the average, the easiest way to find average is just add it and subtract it. Like what is average? Average is nothing but sum of observations by number of observations. So this is we can do, we can add all these things and divide it by 5. But what is the method deviation? So take any number which you think it is in middle. So 50 is a good number, so I'm taking 50 as a middle value. So if 50 is the middle value, now I need to check what is the deviation is there. So 47 is minus 3, 52 is plus 2, 56 plus 6 and 45 is minus 5. So it is basically 5 3s are 8 and whole divided by the number of observation, that is 5. So your answer is 50 plus 0 by 5. So hence your answer is 50. So what is your average? 50. So we can get any number and we can find deviation and we can add or subtract and find the actual average also. This is how we can find average. I'll give you another example of deviation, don't worry. Now think about this kind of numbers. Let's say a number like 123, 127, 150, 142 and 141, let's say. Now this is, you can see this is a very haphazard number and how we can find the average by using deviation, let's say. So you can start with any number, right? So if you can start with any number, let's start with 141, okay? So what is the deviation from 23? So 23 is the deviation kitna hai? That is minus 18. 23, 8 is 31 and 41. 27 minus 14. 50, that is plus 9. 42 plus 1, right? Whole divided by what? 5. So if I do it like it is minus 18 minus plus 9, 10. So that is minus 8 obviously. Minus 8 and minus 14 is minus 22. So if it is 141 minus 22 by 5. So what is your answer? 141 minus 4.4. So your actual average is 136.6. So hence this is your actual average. So you can see like if it is less you can subtract, if it is more you can add. And this is how you can solve a lot of questions by using just variation. So as you understood like how to find average by deviation method, let's go for some properties, right? Let's check. So the following points you need to remember. The first is sum of first n natural number. What does it mean? It means if I add 1 plus 2 plus 3 plus 4 plus dot 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 plus n, what is the sum? That is n into n plus 1 upon 2. That is the sum, right? I can give you an example also. Like let's say the example might be something like, let's say 1 plus 2 plus 3 plus 4 is equal to basically 4. How many terms are there? 4 terms are there. 4 into 4 plus 1 by 2, which is 10. So this is the sum you'll get, right? Now remember, this is of first n natural numbers. First n natural numbers. It has to start with 1 only. If it is not starting with 1, you cannot use this directly. Then you have to do some other techniques. We will discuss it later as well. Okay? Now if the sum is n into n plus 1 by 2, what is the average? So average should have been, that is n into n plus 1 by 2 whole divided by n, because n is the number of terms, so it is n plus 1 by 2. Yes or no? And also remember, average is basically always in the middle value. So the middle value of 1, 2, 3, 4 is like the 3 and 2's middle value, which is also 2.5. Clear? So this is the average. Now average of first n odd numbers. Think about it. I give you an example. First n odd numbers is like, what about 1 and 3? What is the average? 2. What about 1, 3, 5? What is the average? 3. What about 1, 3, 5, 7? What is the average? 4. So if there are n numbers, n first n odd numbers, the average has to be n. For 2, the average is 2. For 3, the average is 3. For 4, the average is 4. Right? So what is sum then? What is the sum of first n odd numbers? The sum, it has to be n square. Clear? The sum is n square and the average is n. Now average of first n even numbers. First n even, like I can say first n positive odd numbers, better. First n positive even numbers, let's say. So it is 2 and 4. What is the average? 3. 2, 4, 6. What is the average? 4. 2, 4, 6, 8. What is the average? 5. So can you see this is basically 2 plus 1, this is 3 plus 1, this is 4 plus 1. So what is it? Number of terms plus 1, that is the average. Number of terms plus 1 is the average. So if the average is n plus 1, what is the sum? The sum is n into n plus 1. Just the double of it. N into n plus 1 by 2, this is n into n plus 1. So these are the like 4 very important things you need to remember. And this is a very important like understanding also, like exactly why we are going to do this and how exactly it happens, right? So this is a very crucial part and you should remember this. Now the next thing is average of n terms in arithmetic progression, which I have n plus 1 term. Now I'll give you the example of this, right? So arithmetic progression means the equidistant term. Okay? So average of n terms in arithmetic progression, n term is n plus 1 term by 2 term is equal to middle term with n is odd. So think about it like this way. Think about like this way. 3, 7, 11. Take 3, 7, 11. What is the average? The average is 7. So as because these are equidistant, remember the average always lie in between, in the middle. If it is an equidistant term, let's say 2, 4, 6, 8, 10. What is the average? 6. And 6 is the middle value. So the middle value is the average, right? So the average, we can say it is a middle value. And this middle value is which term? It is basically 5. There are total kitna terms hai? 5 terms hai. So the average is 5 plus 1 by 2th term. So which is third term. Hai na? And what is third term? 6. So you understand why the average is the third terms. Very, very important. So if it is equidistant, remember the average is always the middle term. Always the middle term. Now remember one thing also very crucial here, that the average of like let's say m terms which are equidistant or in arithmetic progression or in progression, if the number of terms are even. Let's say give you the example. Let's say the example is now 2, 4, 6, 8. So if these are even number of terms, so your average is average of the middle values, which is 5. The average of the middle values. याद रहेगा 4 and 6 का average कितना है? 5 है. If I do it like 2, 4, 6, 8, 10 and 12. What is the average? 6, 8's average. What is 6, 8's average? It is 7. So average of the middle values, right? So it is basically what is the total number of values? 6. So it is the third term, it is the fourth term. That is n by 2th term and n by 2 plus 1 term by 2. That will give you the middle value. And remember, this is how we can find the middle value. So in case of equidistant numbers, the average is always middle value. Odd number of terms, you'll get direct the middle value. Even number of terms, it has to be the average of the two middle values. This thing you have to remember. Otherwise, this kind of things can be generated. But your logic has to be as simple as this, right? Next is the average of n terms in arithmetic progression, whether it is odd or even. Whether it is number of terms is odd or even, if the numbers are equidistant, like 3, 7, 11, like another way we also can answer this question is first term plus last by 2 is the average. It's for everyone. It's for even odd number of terms, even number of terms. Check this. 10 plus 2 is how much? 12. 12 by 2 is 6. 11 plus 3 is 14. 14 by 2 is 7. 2 plus 12. 14 by 2, that is 7. Clear hai? Now this is also same as second term plus second last term by 2. ये भी, that will also give you average if the numbers are equidistant. Third term and the third last term, the average of third term and the third last term will also give you the average, because these numbers are equidistant. So in case of equidistant, if you see, it always go on like this. And you have to remember another thing very important here. In case of this kind of properties, this is very useful while you solve questions, because in some questions you just need to use these properties only. So please pay proper attention. Next is, if each term in a set is increased by value k, then the average is also increased by k. Yes, I give you example. Let's say that sequence is 2, 4. Let's say 8, 10. So what is the average here? The average here is 6, right? Right? Now if all the values are increased by, let's say 3, so it will become 5, it will become 7, it will become 11, and it will become 13. Then the average will become 6 plus 3, which is 9. So that is what is said. If each term in a set is increased by the value k, then the average is also increased by k. So here k is how much? I have taken k as 3. So initially the average was 6, now the average is 9. If each term in a set is decreased by the value k, then the average is also decreased by value k. Similarly think about this example only. So 2, 4, 8 and 10. What is the average? The average is 6. Now just do minus 1. So this will become 1, this will become 3, this will become 7, this will become 9. So what is the average now? 6 minus 1, which is 5. Now if 5 is the average, think about it very carefully. If 5 is the average, 5 is basically what? 6 minus k. So if I subtract by k, if all the values are subtracted, then the average should be subtracted. Remember, it should be happening in all the values. Remember, it has to be happening in all the values. Very, very important thing. Now next is, if each term in a set is multiplied by the value k, then the average is also multiplied by value k. Similarly, take this example only. 2, 4, 6, 8. Sorry, not 6. 2, 4, 8, 10. What is the average? 6 is the average. Now if I multiply by 2, this will become 4, 8, 16 and 20. So your average also becomes 6 into 20. 6 into 2, that is 12. Similarly for division also. I don't need to check with division. So that means average is conserved under all algebraic operation. So it's a very important point to remember, and very important it is also, because you have to remember, if it is equidistant things, that is the one case. If the numbers are being added by the same, if they're being subtracted by the same, then there is no change in average. And you have to remember all of these things one by one. So I have already given you like 10 properties. In the next class, we will start from here only. And the next class, we will go for some further things about average, and we will learn some more tricks as well. So see you in the next class, where we'll learn a lot more about average, and we will discuss some questions about basic average as well. So see you guys in next video.